In this video, we are going to be representing the distributive property. Let's begin. So in example 1, Joanna wanted to make a gift package with treats for her cousins. She wanted each package to have 3 cookies and 4 lollipops. Draw a picture to represent how much of each item she was sending out if she has 2 cousins. Well, if she's got 2 cousins, you're going to need another set of 3 cookies and you're going to need another 4 lollipops because you want each person to have the same thing, which makes a total of 6 cookies and 8 lollipops. Wow, how fancy. This story can be represented as an algebraic expression using the distributive property. So what is that? Well, if I'm going to write this as a mathematical expression, I'm not going to draw a bunch of cookies and lollipops. What I'm going to do is I'm going to write it like this. Well, sort of like this. You'll understand more. But here I have, instead of drawing 3 cookies, I just write 3 cookies because this is like 3 times a cookie, which is 3 cookies. And instead of writing 4, drawing 4 lollipops, I just say 4 lollipops. Notice there's a plus between because it's like 3 cookies and 4 lollipops. Because imagine, like, we're not subtracting the lollipops from cookies or anything. It's just and. So, it's both of them together. So that's addition. Now, these parentheses are like our little package or our box that we put the package in. So right here, this is the package. These are the packages. And the outside, this 2, what does this represent? Well, this is the number of packages she's sending out. So she's sending out 2 because she's got 2 cousins. So 2 of this package. So B, rewrite this expression using different variables. Instead of using cookies, I'm going to use C to represent cookies and P to represent lollipops. So I'm still going to have 2 cousins with that package. Instead of writing a cookie, I'm going to use the letter C. So 3 cookies and 4 lollipops. So 4 lollipops. Now, we use P for lollipops instead of L because, well, first they told us P, but also L's kind of look like the number 1. So we want to avoid certain variables. Anyhow, that would be how we could write it as an algebraic expression, a different kind of algebraic expression without pictures. C, simplify the expression by using the distributive property. How many total cookies and lollipops will Joanna send out? Well, the distributive property simplifies this. What do I mean by that? Well, what we do with the distributive property, it's not complicated. It just means we're multiplying each number. So 2 times 3 cookies, that means she needs 6 cookies. And then she's going to also need to multiply 2 times the 4 lollipops. So 2 times 4p, that's 8p. So when I simplify, it tells us, oh, we have 6 cookies and 8 lollipops. Now, some people call this the double rainbow because single rainbow and then the double rainbow, or they've got different names for this distributive property. But either way, that's what you're doing. You're doing 2 times the first term and then 2 times that next term. D, rewrite a new expression that shows what happens if Joanna sent out 10 packages. Well, instead of sending out 2 packages, she's going to send out 10. So that first term is going to be a 10. And then now we just make the packages. Remember, it's the same package. So it's going to be 3 cookies and then 4 lollipops. So the package itself doesn't change. But, because she's sending it to 10 people instead of 2, that's what happens. Now they want us to simplify this expression right here. So instead of 2 people, it's 10 people. So let's do that. Let's distribute. So 10 times 3 cookies, that's 30 cookies. And now 10 times 4 lollipops, that is 40 lollipops. So 30C plus 40P is our simplified expression. All right, next section, directions. We need to write an algebraic expression for each verbal expression below. So with these expressions, you're going to have some distribution, some parentheses, packages, numbers. Anyhow, let's begin. 2 times the sum of 4 and 9. I'm going to highlight these 2. And let's think about it. The sum of 4 and 9, well, a sum is an addition problem, and 4 and 9, and if you need to write the sum of 4 and 9, it would be 4 plus 9. Now you're going to multiply this by 2. So you're not just multiplying 4 by 2, but you're multiplying the sum, so the whole thing by 2. So what you're going to do is you're going to package it, put it in parentheses, and you're going to multiply it by 2. Now, this is completely different from this. If you just did 4 plus 9, the sum of 4 and 9, times 2, you would write it this way. And this would be absolutely wrong. You would get a different answer if you simplified this. So this is incorrect. You have to multiply the whole thing, the sum of 4 and 9 with 2. Anyhow, let's look at number 4. 4 times the difference of 12 and 7. Pause the video if you'd like to try it on your own. I'm going to keep going. The difference of 12 and 7. I'm going to start with that. The difference of 12 and 7. A difference is a subtraction problem. So 12 minus 7. Now, 12 goes first because it was a number that was mentioned first, and 7 was mentioned second, so it goes second. That's how that works. So the difference of 12 and 7, and you're going to multiply that by 4, so put it in a package and multiply the whole thing by 4. All right, number 3. 6 times the sum of a number and 20. So the sum of a number and 20. The sum of a number, well, you're going to add two things. You're going to add a number plus 20. What number? Oh, well, if we don't know, we're going to use a variable. We use n for our number. So if you're going to add a number plus 20, and you're going to do 6 times it, well, put in a package, multiply it by 6. Let's try number 4. You can try on your own if you'd like to by pausing the video. Twice the difference of 5 in a number. Well, twice the difference of, the difference of 5 in a number, difference is a subtraction problem. 5 in a number is 5 minus, because this is a difference, a number I don't know, so it's put a variable there. And we're going to do twice of that. Well, twice means like 2 times it, so it's like 2 times this difference of 5 and n. All right, number 5, the quantity of 8 in a number times 9. Quantities, this is kind of a weird word. Basically, it's an addition problem. The quantity of 8 in a number, well, that's 8 plus a number, or 8 plus n, because we don't know what that number is, times 9. Oh, well, you just multiply by 9. Now, if you wanted to, you can put the 9 afterward, and it gets you the same answer, or it's the same answer. Anyhow, number 6, this is a confusing one. The sum of 1 and twice a number multiplied by 3. Well, let's start off with the sum of 1 and twice a number. It's an addition problem. We're going to add 1 and twice a number. Well, 1 plus twice a number. Twice a number means 2 times a number. 2 times some mystery number. So that's 2 times our mystery number, 2n. Or we can write, and you're going to multiply this whole thing by 3. So package it, multiply it by 3. And that's how you write these algebraic expressions. Let's look at the next section. Simplify the expressions by using distribution. All right, so we are just going to simplify this. So 4 times 2x, that is just 8x. 4 times 5, well, that's just 10. And notice I just brought down the plus sign. Later on, you're going to recognize that you can't just bring down the plus. You may be multiplying by negative numbers on the outside, but don't worry about that for right now. Just kind of follow along with what we've got. Let's box our answer. And this is how we show our work. We use our distribution rainbows. Anyways, 5 times y. Well, you're just multiplying it by 1y, and 5 times 1 is 5, and then you've also got that y, so 5y. 5 times 4 is 20. Bring down the plus sign. 5 times 4 is 20. Box that answer. That's it. 2 times 3, well, that's 6. Bring down the plus. 2 times 7n, well, that's 14n. That's it. Box your answer. You can pause the video and try these on your own if you'd like. 9 times 4m, that is 9, 18, 27, 36. 36m. 9 times 1, notice I brought down the minus sign. 9 times 1 is 9. That's it. Box your answer. 12 times x, that's 12x. Bring down the minus sign. 12 times y is 12y. Box your answer. 2 times 3x, that's just 6x. And 2 times 8y, that's just 16y. Ooh, this looks kind of weird, but we're going to do the same thing. Multiply 2 times that first term. 2 times 3k is 6k, and bring down the minus sign. 2 times 5 is 10. Now, what you don't want to do is you don't want to do 2 times 5, which is 10, minus 2 times 3k, which is 6k, because 10 minus 6k means something completely different, because when you subtract, the order of the numbers actually matters. So do it this way. Anyways, let's do number 14. 10 times 7e, that's 70e. Bring down the plus. 10 times f is 10f. Box that answer. And finally, 15 seems confusing, but it's not. H times 3 is 3h, or h times h3, but people always write the number first. And now we're going to multiply h times k, which is just hk. So 3h plus hk is your answer. Box your answer. All right, rewrite the expression by factoring out the GCF, or the greatest common factor. The directions may also say rewrite the sum or difference as a product of the GCF and another sum or difference. So basically, you have these, and you are going to factor out the largest number you can. What we want to do is we basically want to do the opposite of this. So you've got this answer, or you've got these answers right here, like 70e plus 10f, and they're asking you to turn it into something like this, something like the problem. So like, anyhow, the way you would do this is to find the GCF. I do this upside down ladder thing, uh, or like it's like double division. You're asking yourself, well, what can you divide both 6 and 10 by, or 6x and 10 by? And I could divide both numbers by 2. And if I divide 6x by 2, I get 3x, because 3x times 2 is 6x. How many times 2 go into 10? Well, it goes in 5 times. And now this is all I can do because I can't divide 3 or 5 by anything. So I just basically bring these things straight down and write my answer. So 2 goes on the outside, and then, I start my package. My package has a 3x and a 5 inside, and you bring down the plus sign. So bring everything down. The plus sign, bring down the 5. Close your package, and that's your answer. You can try the next one if you'd like. I'm going to keep going. Upside down double division, this latter method. What can you divide both 12 and 24 by? Some of you may be quick and you may say, 12. But let's say you're not that quick. Let's say you thought 2 works. So 2 times what equals 12? Or 12 divided by what? By 2 equals what? Well, you get 6x. 2 goes into 24 12 times. And can you divide 6 and 12 by anything? I know, 6. So let's divide both terms by 6. 6 divided by 6 is 1, or 1x, and 12 divided by 6 is 2. And I can't divide both 1 and 2 by any number, so the GCF is these two numbers, which you multiply together, and those numbers multiplied together is 12. You don't add them together. It's not 8, so multiply them together. So 12 goes on the outside, start your package, and you're left with 1x left, which you can just simplify to x, bring down that minus sign, and then bring down the 2, and that's your answer. So you're bringing down like the bottom numbers, and you're just multiplying those two together. You can try 17 on your own if you'd like, but I'm just going to keep doing this. So what can you divide both 32 and 12 by? Well, I'm going to divide it by 4. So 4 goes into 32x 8 times. It goes into 12 3 times. Can I divide both 8 and 3 by anything? No, I cannot. So bring it down. 4, package, 8x, bring down the plus sign, and then 3y. Close your package, and that's it. Finally, our last two problems. They want us to rewrite the verbal expression by turning it into an algebraic expression in 2 ways. So this is our verbal expression right here. How do we turn this into an algebraic expression? At the beginning of the year, Mrs. Rainey gives each student 5 pencils and 2 markers. Write 2 algebraic expressions to show how many pencils and pens she will need if she has 20 students this year. Well, think of it this way. She's got 5 pencils and 2 markers. Well, you're not going to say minus 2 markers. That'd be weird. But 2 markers, well, let's call that 2m. And let's add that together. And remember, this is like a package. So package it up. And she has 20 students this year. So 20 of these packages. Now, what's another way we can write this algebraic expression, because they want us to write it in 2 different ways? Well, we can simplify this. And we simplify this by doing distribution. 20 times 5p is just 100p, and 20 times 2m is just 40m. So 100 pencils and 40 markers, or 20 packages of 5 pencils and 2 markers. All right, let's do the last one. You can try it on your own if you'd like. Billy Bonka makes boxes of chocolates for sale. 100 customers ordered boxes on Monday. Each box contains 6 milk chocolate pieces and 3 white chocolate pieces. Write 2 algebraic expressions to how much of each chocolate he will need to pack. So let's think about it. Each box will contain 6 milk chocolates, so 6 milk chocolates, and 3 white chocolates. So I'm going to use 3W, W for the white chocolates, and add them together because I need both of them. Anyways, you're going to package it, box it, and I have 100 customers ordering it. Well, that means 100 customers ordering this package right here. Now, what's my other way of writing it algebraically? Well, I simplify it by doing distribution. 100 times 6m, 100 times 6 milk chocolates is 600 milk chocolates, and 100 times 3w is 300 white chocolates. So now we know how to write algebraic expressions using the distributive property. We know how to distribute, and we know how to do the opposite, which is to factor those factor numbers out. Go ahead and try some problems on your own. Good luck.